Did not do these last problems right here. Example 7, we did not do these problems. So let's look at these here and see what we can do with them. The first part of example 7 is going to be a very easy problem because when I've got 2 to the 5x minus 1 equals 2 to the 2x plus 7, what do you guys think we should do? We can log base 2 both sides, and when I do that, it just basically cancels out the 2 on both sides, right? So I just get 5x minus 1 equals 2x plus 7. Right? And that makes sense because if my base is the same on both sides, then the exponents would have to be equal to each other. So then I just have like a two-step equation to solve. I'm going to subtract that 2x right there. I'm going to add that 1 right there. So that'll give me 3x equals 8. And then I will divide by 3. And so x equals 8/3. Okay, questions there? So if you see one with the same base, you're just setting those exponents equal to each other. But if we look at B, what's the problem here? Bases are not the same. So if I try to use logs right away, right here, it's only going to work on one side, right? So if I do log base 8, it will get rid of the 8 on the left side, but it's not going to do anything on the right side. And then I'm going to have this like complicated equation. If I do log base 2, it'll only cancel out the 2 on the right side. It will not work on that 8 on the left side. So what we want to do is we want to try to first rewrite this where we have the same bases. It is lots of times better to go with the lower number so that you don't have to use like negative exponents or something. So it's usually better to go with the lower number there. Like D is a little bit of an exception there. Well, C is going to be a little different too. Sometimes you have to change both of them. So in this case though, 8, can I write it as 2 to some power? I can. It would be 2 to the 3rd, right? So I could write it like this. 2 to the 3rd to the 3x minus 2 equals 2 to the x plus 5. And when I have this right here, when I have a power raised to another power, what do I have to do with those exponents? I multiply them together, right? Remember, like if I've got x squared times x to the 3rd, I add the exponents. I get x to the 5th. But in this case, that's not what I've got. I've got x squared to the 3rd power, x to the 6th. I multiply. That's just like a separate example to remind us here. So I need to multiply those together. Essentially, you are just going to distribute. So I got 2 to the 9x minus 6 equals 2 to the x plus 5. So now I've got the same bases on both sides. Now I can do log base 2 on both sides, or you don't even have to write that step if you don't want. It cancels. I've got 9x minus 6 equals x plus 5. And now I'm back to what I had in A. So for that, Giovanni, how would I solve that equation? Good. That'll give me 8x minus 6 equals 5. And then? Good. So 8x equals 11. And last thing? Divide by that 8. So x equals 11 eighths. There. Okay, questions there? All right, and D are going to be a little bit different. Because 9, can I raise 9 to a power that'll give me 27? I can't do it, right? Like 9 squared would give me 81. It'd be too big. I could use like maybe a decimal or like a fraction, but I'd rather stay away from that if I can. So I have to have the same bases to be able to solve this. I can't solve it unless I have the same bases. Any ideas? Is there another base I could use that would work for both of these numbers? 3, because 3 squared is 9, right? So I could do 3 squared to the 2x. And then 27 is 3 to what power? Cubed. 3 cubed is 27, x plus 2. So just like we did on the last problem, we would have to multiply those exponents together, in this case on both sides. So we got 3 to the 4x equals 3 to the 3x plus 6. Make sure when you multiply that 3 that you multiply both the x and the 2. And so now I have the same bases, so a log base 3 on both sides would get rid of those bases. I would have 4x equals 3x plus 6 right there. Lucas, what would I do to solve that? Very good. And actually that does it, right? Because that just gives us x equals 6. D's even a little bit trickier. Any ideas on D? Any ideas of what I could use as my base? Okay, if I use a 2, right? So I think the right side's easier. 2 to what power is going to give me 4? 2. So 2 squared is 4. All right, so I got 2 squared to the x power. All right, what about 1/2? -1, perfect. Because 2, oops, parentheses too close there. 2 to the -1, remember 2 to the -1, negative exponents are like bad children. You lock them in the basement. It fixes their bad attitudes. Their exponent becomes positive. You got to keep the 1 in the top. So 1/2 is 2 to the -1. And then I got 5x plus 7. So once you get these written with the same base, you're just going to multiply those exponents. So you'll get 2 to the -5x minus 7 equals 2 to the 2x. And a log base 2 can now cancel those out. And I'll have -5x minus 7 equals 2x. There. Cameron, what am I going to do to solve that? Good. And then what goes last, Cameron? Good. So we get a -1 for our x. Okay, questions? I'm going to pick up from right here. You got 4 times 2 to the x minus 1 equals 8. First step is to subtract that 7. You have to divide that 4. You can't use a log or anything on it yet because the 4 is not the base. It's just a number multiplied out here. So you got 2 to the x minus 1 equals 2. And then to get rid of this 2, you got to do log base 2 right here and log base 2 here, which cancels, but what's left? What does that cancel to on that right side? It's a 1, because this 2 had an exponent of 1. Another way you can think of it right there, you got 2 to the x minus 1 equals 2 to the first power, right? So like you basically are just dropping those, and you got x minus 1 equals 1 because the exponents have to be equal to each other. And then you just add that 1 to get x equals 2. Also, he went with 1/4 on both of those. I bet you guys did not do that, did you? Did you guys do like 4 to the negative 1 to the x plus 2 equals 4 squared to the 4x plus 1, like that? Or you could use 2's also if you wanted to. I would do it this way instead of the way that he did it, but because I really don't like negative. I don't like 1/4 to the negative 2, but you should get the same answer, I think, there. Okay, questions? Looking pretty good whenever I walked around. I was seeing several right answers on that. This is posted on, the key's posted on Canvas tonight, so if you need to look at that longer, you can. The front page is what I'm going to give you for that. So, and you've already done 9 through 12, so it shouldn't take long, hopefully. Hopefully we're talking like less than 10 minutes on that, because you also have the quiz if you haven't done it for that. So, for example 1, it says let h of x equal 3x to the x plus 1 minus 2, and let k of x equal h inverse of x. For what values of x does k of x equal 1? So, they're asking us where k of x equals 1, but k of x equals h inverse of x. I think it's kind of like clunky to even say that. I don't know why they don't just use the h inverse, but they do things like this sometimes on the AP exam, so we got to roll with it whenever they do. So basically they're asking, when does the inverse equal 1? Right? So there's a couple ways you can go about doing this. I'm going to do it both ways. If I was a student who was just learning this, I would do it the long way. It's the way I would probably go about doing this. But there is a shortcut I will show you at the end as well. So if we want to know where the inverse equals 1, we need to know the inverse, right? Or, well, technically we don't, but maybe somebody's mind is going there first. But most of the time students don't think of that first. So if I need to find the inverse of an exponential or any function for that matter, I switch my x and y's, right? So this right here is like your y. So you're going to switch it and make it your x. So x equals 3 to the y plus 1 minus 2. And then you are trying to solve this for the new y. So if I'm trying to solve that for the new y, Hayden, what would I do first? Add the 2. So I've got x plus 2 equals 3 to the y plus 1. So then I'm trying to get that y by itself. Zoe, what would I do next? I do the log with a base of 3 on both sides, and that will get rid of the 3 on that right-hand side. So I've got log base 3 of x plus 2. Make sure you got parentheses around that because you're taking the log of everything on that side, equals y plus 1. And then, Ella, what's the last thing I would need to do to solve for that y? Subtract the 1. It can't be on the inside of that, so you just have to write it like this. I'm going to go ahead and use my h inverse notation. It's going to be log base 3 of x plus 2 minus 1. Okay, everybody okay here? All right, so for this, now that I've got my inverse, I want to see where this inverse equals 1. So what do I have to do? Where's that 1 going to go? it's like our y value on our inverse function, right? So I'm taking this here. This is my y value because if it was the x value, they'd be putting it here. And remember, k is h inverse. So I'm replacing h inverse with a 1. So I'm going to have 1 equals log base 3 of x plus 2 minus 1. And now I'm trying to figure out that x value right there. So if I'm solving this equation right here, oh gosh, sorry. If I'm solving this equation, Stephanie, what would I do first? Add that 1. So 2 is going to be log base 3 of x plus 2. What would come next, Mackenzie? Almost. I think you just said it back. 3 to the power, yeah. And so it'll be 9 equals, this will cancel, and I've just got x plus 2 for that. And then Mackenzie, what's the last thing? Minus that 2. So x is going to equal 7. It's kind of a long process to do that. I don't think any one piece of it is that difficult, but there's a lot of opportunities for mistakes if you do it that way because it's got a lot of steps. So this is definitely an option. But there's also another option. There's another way we could have done this problem. We don't even have to find the inverse. Let's think about this right here, this k of x, or I prefer h inverse of x equals 1. So if the inverse of x equals 1, let's think about what that looks like. If I made a table for h inverse where I had x and h inverse of x, what would the 1, would it be my x coordinate or my y coordinate? Here, if I've got h inverse of x equals 1, is that x or y coordinate, the 1 there? It is our y coordinate right there. Whatever it's equal to is your y coordinate. Whatever is right here is your x coordinate. Do we know what goes right there? We do not. That's what they're trying to ask us for. I'm going to put a question mark right there. Or you can put an x if you want. So that, I'm sorry, I'm trying to make that line shorter. Right there. That would be like our point on our table. We're trying to find this right here. But let's think about what the table for just h itself would look like. If I want to go from the inverse table to the original function table, what do I have to do to my points? I flip my x and my y, right? So that would mean that this point right here would be, my x would be 1, my h of x would be question mark. Okay? So if I want to find h of x whenever x equals 1, all I've got to do is do h of 1, which means plug 1 into the original function. So 3 to the x, I'm sorry, not x, I should put a 1 there. 1 plus 1 minus 2 is going to equal 3 squared minus 2, which will be 9 minus 2, which will also give us 7 for that. This is quicker. I don't know if it's like the first thing you're going to think of whenever you see it, but it's an option for you. Okay, questions? All right. Let's look at example 2. We've got k of x equals 1 minus 4 times 2 to the x minus 3. what are the values of x for which k of x is less than or equal to negative 31? So this one's not asking us about an inverse at all. It is asking us where k of x is less than or equal to negative 31, which if I plug in k of x, if I take this and put it right here, means that we're doing 1 minus 4 times 2 to the x minus 3 less than or equal to negative 31. Okay. Solving inequalities is almost the same as solving equations in a lot of cases, but there's something that we have to remember to do whenever we're doing this. With inequalities, there's a special thing that if we do it, we've got to do the special thing to our sign. What is it? If I divide by negative, or technically multiply by negative, that just doesn't happen as often. If I multiply or divide by a negative, I've got to flip the inequality sign, right? So, this one can just be solved basically like an equation. We just have to keep that in mind. If we multiply or divide by a negative, we've got to flip the inequality sign. So if I'm trying to solve for that x right there, Enrique, what would we do first? Very good. Subtract 1. So I got negative 4 times 2 to the x minus 3 is less than or equal to negative 32. All right. Hayden, what do you think we'll do next? You are correct that we need to do something with the 4, but we don't add it. Because it's not being subtracted. What's happening between that negative 4 and the 2? They're multiplied. So we want to divide by negative 4. And since we are dividing by negative 4, what have we got to do? Flip the sign. So we got 2 to the x minus 3 is now greater than or equal to positive 8. Okay, again, we're trying to get to that x. Ryan, what should we do next? We're going to log base 2 on both sides. Now, this is going to be a calculator inactive question. Okay, what is log base 2 of 8? It's going to be 3. How do you know that? Good. So there's a couple ways to think about that. You could do you can think about it like this. You can think like let's say that equals x, right? 2 to the x equals 8. You're thinking 2 to what power equals 8, and the answer for that would be 3. Or you can think of doing it this way. Log base 2 of 8 is 2 to the 3rd. And when you do log base 2 of 2 to a power, those logs cancel each other out, and you just get 3. So we've got x minus 3 is greater than or equal to 3. And then Ryan, what's the last step on that one? Add that 3. So x is greater than or equal to 6. For that. Okay. This for the log base 2 of 8. So the way I prefer to think about it is like I know that if I've got log base 2 of 2 to some power right here, that the log base 2 and the 2 will cancel each other out. So in this case, 8 can be written as 2 to the 3rd. Right there. So like to do a separate example that doesn't have anything to do with this problem, like if I have log base 3 of 81, that one can be done without a calculator. So since I've got a log with a base of 3, 81 could be written as 3 to what power? Fourth, right? 3 times 3 would be 9. And then 2 more 3s would be another 9. 9 times 9 is 81. So it would be 3 to the 4th. So the log base 3 and the 3 would cancel out, and I would just get 4 for that. So if it's on a calculator inactive section, and the answers are whole numbers, then something like this should happen. They will not give you something like log base 3 of 18 on the calculator inactive section, because 18 cannot be written as 3 to a power, right? Not with whole numbers anyway. So, so they wouldn't give you something like that on calculator inactive. The first part of your homework is going to involve doing things like that. It's going to have things like log base 2 of 8. And what you want to do is get the bases to be the same so that you can cancel those out. Okay, so this pretty much covers everything for the homework that you're going to have. I want you to do the front page is what you're going to do. I do want us to do example 3, but I'm not going to give that to you as homework because we're going to need a little bit more practice with it. Okay, when we have inequalities, but we have more than one log, it's going to make it a little bit more difficult to do the problem. Okay, so when we have inequalities, but we have more than one log, we have to be more careful. And these two weren't log problems, so I didn't have to check for extraneous solutions. But the first thing you want to do when you're solving a log inequality, and in this case, we want to know where f of x is greater than 0. So the inequality we're solving is log of x squared minus 4x plus 7 minus log of x plus 3 is greater than 0. But on a log inequality, you have to only get answers where if you plug them back in, you get positive numbers inside of those logs, right? Like, so when we checked for extraneous solutions on that homework, when we plugged our answer back in, it had to be positive. So the first thing we want to do is think about the domains that go here. So if I've got x plus 3, that means x plus 3 has to be greater than 0, right? Which means that x has to be greater than negative 3. For right now, I'm just keeping that in mind, okay? I cannot, so if I get like x is less than 10, it can't just be x is less than 10 because I can't have any numbers lower than negative 3, right? So I got to keep that in mind. This part right here is harder, and because of time, I got to have this greater than 0. Because of time, there's a way to do this without graphing it. But if I graph it, if I graph x squared, what was it, minus 4x plus 7, is that ever less than 0? It is not. It's above the x-axis the whole time. So in this case, this is just always true, right? So this is just true. So I don't have to do anything special. Tomorrow we'll look at how we can do that without graphing it, but we don't have time to do that today. So if I want to solve this, then I need to combine those logarithms. So I'm going to have log of, if I have subtraction, it becomes division. So I've got x squared minus 4x plus 7 over x plus 3 is greater than 0. What would I need to do next? 10 to the power, because this log does not have a base, which means that the base is 10. So I've got x squared minus 4x plus 7 over x plus 3 is greater than, what is 10 to the 0? 1. Now, this is a rational inequality. One of the good things about this class is like things keep popping back up and we have to remember how to do them. In this case, the easiest way to deal with this is that x plus 3 in the bottom makes it more difficult, so I'm going to multiply both sides by x plus 3. So I've got x squared minus 4x plus 7 is greater than x plus 3. Now, this is quadratic because I have an x squared. What do I need to do when I have a quadratic? What? Factor. But before I can factor, what do I have to do? Can I factor it like it is right now? Move everything to one side. So I'm going to subtract this x, and I'm going to subtract that 3, and I will get x squared minus 5x plus 4 is greater than 0. And this will factor. So I can do x minus 4 times x minus 1 is greater than 0. But when we did these polynomial inequalities, I can't just say like x equals 4 and x equals 1 for this because this is an inequality, right? So these are the ones that we made those charts for. We need to see where this is greater than 0, so we're looking for the positives here. So we're going to put 1 and 4 right here. And then I put my pieces over here, x minus 4, x minus 1, and our answer. Okay, and I'll get negative, negative, positive here, negative, positive, positive. I'm going pretty fast for the sake of time here. Positive, negative, positive on that bottom line. I'll do another one of these tomorrow if I'm going too fast for you. What are my answers, positives or negatives? They are positives, but you do have to be careful about what we were looking at the very beginning. X has to be greater than negative 3. So right here at negative 3, I can't go past negative 3, right? Because if I do, I'm going to get negatives in that log, and it's going to give me an invalid answer. So whenever I do this first piece, I need to do negative 3 to 1, and then the other piece will be 4 to infinity. Those will be my answers there. Okay, the homework doesn't have any of this. We will do some more of it before I have you guys do that assignment. So tonight, I just want you to do the front page of that worksheet, 1 through, is it 14, I think? But you